So, you watched those two videos, and that is how the moon appears. One was kind of a satellite orbiting the moon and having you take a look at it from all different sides, and the other was the moon as it appears from Earth over the course of a certain year. And I want you to ask yourself a couple of questions. First of all, what did you notice? And you should have noticed a few different things happening here that should kind of hit your radar a little bit. I want you to have your notes out here. I want you to kind of think about what we're going to do. We're going to take some notes. It's going to be a little bit dense, but take these notes and just get down what you can here a little bit. So these are some things you should have known. Again, if you need to pull out a notebook, pause the video at this point and get out a notebook to do this. But one is that as viewed from Earth, the moon always shows the same side. We didn't know what the other side of the moon looked like until we actually sent NASA missions and were able to get around on the far side of the moon. We only see one side. We call that the near side of the moon. A second thing you might want to notice is that during the course of the year, and even during the course of the month, the moon actually appears to get larger and smaller in the sky over the course of a month. A third thing you might notice is that the moon has phases, and that's actually going to be a large part of what we're going to talk about over the next week or so, is the phases of the moon and why the moon has phases and how you can recognize the relationship between the Earth, Sun, and the moon by the phase that the moon's in, and why you see certain phases of the moon at certain times of day and not others. And the last one we're not going to focus on, but you probably should have seen that the moon appears to wobble a little bit, and that's actually explained by the fact that the moon's orbit around the Earth is actually tilted a little bit compared to the Earth's orbit around the sun. So those are some things that you may have noticed as you watched those videos. Now, one of the videos illustrated the fact that the moon always shows the same side. So what does the far side look like? Let's get this out of the way here. And you'll notice that there's actually a pretty extreme difference between how the near side and the far side appear. Okay, and I want you don't have to draw those, I don't expect that, but there are going to be some features here that I'm going to expect you to notice between the near side and the far side. The coloration is very different, but this side over here, this is what we're looking at night after night. We never see this side of the moon, and this should look very unfamiliar to you, but there's some key differences here. One of them you should notice is that it certainly appears that this side has a lot more kind of crater impacts over here. Okay, it seems like there's lots of crater impacts here, here, all over the place. This looks like 10 miles of bad road. This looks like it's been through the ringer a little bit. Whereas this side has all these dark areas, and you'll notice that they appear somewhat circular. Okay? And when Galileo first looked through one of the world's first telescopes and looked at these in detail, he thought that these dark areas were kind of like oceans. Okay? And so he named them the Latin word for seas, which is mare. And what they are is they are actually craters that are filled with cooled lava. So imagine you had a crater and then it was filled with lava, and that lava is that dark material. Okay, so these dark areas are actually lava that has come up from beneath the moon's surface and has leaked through and filled these broad plains here that are circular. Okay, so the term for those dark areas are called mare, and the plural is Maria or Maria. That's the plural for that. These are dark areas on the moon's surface that are filled with cooled lava. The question you might have is, why are they only on the near side? Why don't we see these mare on the far side? Because we have craters over here. Okay, why don't we have them on the far side? Well, here again is another illustration. They've named all these mare, and what the names mean are basically the names of oceans. So the ocean of storms, the Sea of Serenity, the Sea of Vapor, the Sea of Tranquility. You'll see that there are several of these that are very distinct features on the near side of the moon. But the reason why they're only on the near side of the moon is a little bit complicated. When the moon formed, its mass wasn't equally distributed. And this outer area here is what we describe as being the crust of the moon. And if you look carefully, you'll notice that the crust is not the same thickness. This is like a Papa Murphy's thick crust. This is like a Papa Murphy's thin crust. It's thinner on the side that's facing the Earth, and that's because of the Earth's gravity during the moon's formation. And it ended up that some of the lighter stuff of the moon ended up this way, and some of the heavier stuff ended up this way. I'm getting a little bit messy here, so I'm like a graffiti artist. I got a mess going on here. But because this near side is thinner, what happened is that you'll notice here it kind of got broken in the crust here. Okay? And in those areas where the crust got cracked, some of the lava from beneath came up, leaked through, and filled these areas on the lunar surface on the near side of the moon, which is why the near side has these and the far side does not. The far side is a thicker crust, the near side is a thinner crust, and so that lava leaked through. But why does only one side of the Earth face the Earth? Okay, or one side of the moon face the Earth? And it's because, as I suggested earlier, the mass of the moon is not evenly distributed. Even though the crust is thinner on this side, there's actually a little bit more mass, on this side of the moon. Okay, this side of the moon is a little bit heavier than this side of the moon. Okay, it's a little bit heavier. Now think about this. If I threw a bowling pin up, the heavy side would usually be the one that would fall to the ground, right? Okay, it's very difficult to throw a bowling pin up and get this side to hit the ground. The heavy side would hit the ground. So think of the ground as being the Earth. The heavy side of the moon is always going to be falling towards the Earth. It's always facing the Earth, which is why we are only going to see this side of the moon. That side of the moon is the heavy side of the moon, so that's always going to be facing the Earth as a result. Okay, the heavier side of the moon faces the Earth, and we're going to see more visible craters on the far side because they haven't filled up with that lava. So you see more visible craters on this side because they have not filled up with that cooled lava. Now, a second feature we noticed is that in order for the same side of the moon to always face the Earth, the time for the moon's rotation, its spinning on its axis, has to equal exactly the amount of the moon's revolution around the Earth. So if I have the moon orbiting the Earth, that takes 27.3 days. So in the 27.3 days it takes for the moon to go around the Earth one time, the moon only spins on its axis that one time. Let me show you what I mean by this. So the way I've drawn this so that this near side is facing the Earth right now. Okay? When I go around over here, the near side would be on this side of the moon. The moon is rotated 1/4 of the way around in the time it's revolved 1/4 of the way around. Now the moon's gone halfway around in its orbit. The far side of the Earth would be on this side. The near side would be on this side facing the Earth. It's turned another quarter, another 90 degrees. It's turned halfway around. By the time it gets over here, we're 3/4 of the way around. The far side is on this side of the moon. The near side is here. So in the time it takes to revolve once, the moon has only rotated once. The rotation exactly equals the revolution. And this is described as being tidally locked. The moon is tidally locked. We're only going to see one side of the moon. Now, a second feature, or another feature you probably noticed, is that the moon appears larger and smaller, and it's not insignificant. In fact, the moon is going to appear as much as 14% larger when it's at its largest as viewed from Earth as when it's smaller. And we're going to introduce a couple terms here. When it looks big, the moon is at perigee. When it's far away, it's described as being at apogee. And you can see here that that is a significant difference in size as viewed from Earth. It's not like the moon is getting bigger and smaller. It has to do with the fact that the moon is not always the same distance from the Earth. Just like we talked about the fact that the Earth is not always the same distance from the sun, The moon is not always the same distance from the Earth. And we describe when it's closest as being at perigee, and when it's farthest away is going to be at apogee. So this is going to be when the moon appears big. This is going to be when it appears small. And since the moon takes 27.3 days to revolve around the Earth, we're going to see it at perigee and at apogee each month. So what do these terms mean? They're not just made up names. They're not bad names for your firstborn kids. Okay? They actually should sound kind of familiar to two words that we have hit so far. If you remember, we talked about a term called perihelion. Whoops, bring this up here. Actually, why don't I type this puppy out? We brought up the term perihelion. Let me do that. It's not let me do that. Yeah, it will. Perihelion. And we brought up the term aphelion. So you can see that those look kind of similar. And perihelion meant that we were close to the sun. Helion means sun. Ap meant that we're away from the sun. So this is perigee and apogee. There are a lot of words that begin with the term G. Geology, geography, geometry. Okay? And the word G in that case means earth. Okay? Geometry is the measuring of the earth. Geology is the reading of the earth. Geography is the graphing of the earth. So perigee means basically that we are near the earth. That is when the moon is going to appear largest, and that's when it's closest in its orbit. Apogee means away from the earth. That is when the moon is farthest away from the earth in its orbit, and that's when the moon is going to appear smallest. Now, the big idea that we're eventually going to hit next week is going to deal with moon phases, but that's going to take a little bit more time than we have today. What I'd ask that you do is that you try the Google form. It relates to these notes. See how well you do on it. See if you learned anything. And then I've got a Google document that I'd like you to read through and answer the question, which poses the rather serious question: what would be the ramifications on Earth? What would be the coincidence, or the consequence, I should say, if the moon disappeared tomorrow? What would happen on Earth? How would that affect us? So I'm going to sign off, finish the Google document, and finish the Google form. Finish the Google form first, and then go on to the Google document. And we will see you next time.